fluorine, chlorine, bromine, iodine. Recently, astatine and tennessine have been discovered, but these
Yeah.
are not studied because they are radioactive in nature. Okay,
Yeah.
they are not stable. So usually we study these four.
Yeah.
Right? And fluorine is gaseous in nature at the room temperature. Fluorine is also gas. Bromine physical state is,
Liquid.
and that of iodine
Is it liquid as well?
solid.
Oh, solid.
Yeah,
Ah.
at room temperature. Okay. Some black purple color solid.
Yeah.
You must have seen in your laboratory, isn't it?
Yeah. Well, the one we use is like a iodine solution, so we don't. I haven't seen it in solid form before.
That must be the aqueous solution of halide ion.
Mm.
Like you might have
Because
used sodium iodide aqueous solution.
because what we used was chlorine water and bromine water and iodine solution, and then we did an experiment with different halides
Yeah,
and the
yeah.
reactions with halogens for displacement.
In that, the aqueous solutions are used by
Mm.
dissolving them in water. Okay.
Yeah.
And okay, I'm talking about their physical state at room temperature.
Oh, okay.
And you know, bromine is liquid at room temperature and reddish brown in color.
Mhm.
Fluorine,
So
some greenish gas.
yeah.
Similarly, fluorine, yellowish green.
Mm.
And iodine, purple, black crystals are present of iodine.
Yeah.
Yeah,
Can I just make a note of that very quickly?
yeah. I can also send you the recording if you want.
Yeah.
Are you there on Telegram? It's easy to send the recordings on Telegram.
Telegram?
Yeah. On WhatsApp,
Uh,
actually, I think there is limited GB, something like that.
yeah.
You can't
Um,
send heavy recordings.
yeah.
Recently, I got to know about this point. My students told me. So I made
Yeah.
their groups on Telegram and send the videos.
Okay. I'll download it then. Liquid, solid. So they haven't like looked into the properties of what's it called? Acetine?
Astatine.
Astatine. And what's the other one?
This is tennessine.
Tennessine. And they are radioactive.
Yes. So they are not
Okay.
stable. So usually we don't study their properties.
Yeah. Reddish, purple, green, and yellow.
So how
Yeah,
was the
that's fine.
biology class?
I didn't get to do the biology class.
Why?
He missed it. He didn't come. He didn't. First he said 4 o'clock, and then I waited at 4. I woke up like 9 o'clock so I can be ready, and then he said 5 o'clock to 5:30. So I waited at 5 o'clock, then 5:30 as well, and then he still didn't show. So I said it's fine, but cancel it.
Okay, okay.
So
Mansar was there.
hmm?
Mansar, no, I don't remember his proper name. We call him Mansar. Mansar.
Yeah. I'm not sure. Maybe
Okay.
that's him, but
He may be busy. I don't know.
yeah. So we just said, we'll find someone else because sometimes it's difficult with the timing, with
Okay.
the your timing and my timing.
Mhm.
But yeah.
Okay. Do you know what is the meaning of bond energy? We studied in
But
thermodynamics.
the the energy required to make a bond.
Yeah, make a bond or break a bond, isn't it?
Yeah. Yeah.
Okay. And please tell me, do you understand diatomic gas?
Yeah, like isn't it like oxygen, nitrogen, fluorine,
Yes.
chlorine, bromine, they're all diatomic. They
Very
come
good, very
in
good.
molecules.
And please remember, I don't know whether this point is given in your book or not. Halogens, they are represented with X, capital X.
Oh, okay. I didn't know that, so halogen. Okay. Yeah.
And all the halogens, they exist as diatomic gas. So can I write like this X2, journal notation?
Yeah. Yeah.
F2, Cl2, Br2, I2, isn't it?
Yeah.
So why I have written F only? These are just the symbols of the elements.
Yeah.
Now, do you understand that there will be single covalent bond between FF, Cl, Cl, Br, similarly iodine?
Yeah.
How? Because, okay, please tell me what are the number of valence electrons in group 17, or you can say group 7.
So would it be 7?
Yeah. So
So they need one more
what
electron.
type of bonding will be there between them?
But just a single bond?
Covalent, single covalent bond sharing because they are
Yeah.
non-metals.
Yeah.
Okay, fine. That's why I have shown this. Okay. Now, please tell me what about the size of the atom if we move down the group?
Does it get bigger because there's more energy levels?
Yes, fine. So now if I want to break these bonds, what do you
Yeah.
think? Which bond should be strongest? That of fluorine, chlorine, bromine, or iodine?
Would it be fluorine because it's a smaller atom, so there's
Yeah, yeah.
stronger bond?
Now, some sort of this picture comes in our mind, isn't it?
Yeah.
Now, my next question is, like if you are saying this is the smallest one, so their bond should be the strongest, isn't it?
Yeah.
So if we see, if I'm saying suppose 200 energy is required to break this,
Yeah.
we'll say कि ma'am, this need 150 energy,
Yeah.
this need 100 energy, this need 50 energy. Why so? Because this should be the strongest.
Mm.
Are you getting my point?
Yeah, yeah, I understand.
But there is an exception. What is that exception? I'm going to write. First, I'm writing here expected trend. Do you understand expected? Means what we feel should be the normal.
Yeah. Yeah.
Expected trend of bond energy. I want to write, suppose, decreasing order of bond energy. So what is the expected trend? Ayush, fluorine should have highest, then chlorine, then bromine, then iodine, isn't it?
Yeah. Yeah.
But what is the actual one? Actual trend is, it has a reason, but first let's see what is the actual trend. Instead of being the highest bond energy of fluorine, it comes after bromine.
Okay.
This is the actual one. Now let's see what is the reason for this. Okay.
Yeah.
So please remember, this is which part of chemistry? Inorganic.
Yeah, inorganic.
Okay. Ayush, in inorganic chemistry, there will be lot of exceptions.
Okay.
These are the two words. This is expected, which should be the trend.
Yeah.
Exceptions means not normal. Okay.
Yeah.
And in inorganic chemistry, you need to remember lot of things.
Hmm.
Actually, the inorganic chemistry is the study of the basically about the behavior of the atoms and molecules. So how this inorganic chemistry is being studied? First, the scientist found that this atom is behaving like this atom is behaving like this. The reasons of some of them are very well explained, but some points sometimes you have to remember. Okay,
Yeah.
I'm just telling in general, but we have the reason for this, very good reason. Let's see what is that. Do you know lone pairs? I
Yeah.
think we studied, no?
Yeah.
If I draw it again, the electron dot diagram,
So it has 3 lone pairs.
on every fluorine there will be 3 lone pairs.
Yeah.
Chlorine also similarly will have 3 lone pairs. Now you may ask, ma'am, there is no difference, but there is difference. We know that the size of the fluorine is very small, so isn't it their lone pairs will be closer to each other?
Yeah.
This lone pair will be closer to this as compared to this and this.
Yeah.
And you know that
Uh,
there will be lone pair repulsions.
yeah.
So why? Because they are basically what? They are basically electron cloud.
Yeah.
Do you understand electron cloud? Like this is the negative charge, suppose this is a negative charge, and they are very close to each other. So they
Yeah.
will repel each other to such an extent that it will lead to the breaking of their bond easier. So less energy will be required.
Yeah.
So
That makes
that's
sense.
why instead of being highest bond energy with fluorine, it comes after bromine. Actually, we need to keep the exceptions in mind because the questions in the inorganic chemistry will definitely come only from the exceptions. More chances
Yeah.
are there. Like in your book, if we see, first they discuss little bit about the, you can say like pale. Do you understand the meaning of pale?
Pale, like, is it slightly colorless or?
No, pale yellow means light yellow.
Oh, okay. Yeah.
Yes. Chlorine, greenish gas, as we discussed, bromine, red brown liquid, and iodine, black purple solid. But
Yeah.
sometimes purple, they have not mentioned it. Okay. And then they have written this, not that detail, but we have discussed. Okay. Non bonding electrons, lone pair. They have
Yeah.
shown the color of the halogens. This is bromine clear cut, so you can see some purple color here. It's a
Yeah.
chlorine, it's a fluorine. Now you can see they have written the values. No need to remember it. Highest is that of with
Chlorine.
fluorine, then bromine. Then you can see fluorine is coming at the third number. Last is the iodine.
Yeah.
Okay. Size of atoms, you already know it becomes bigger on moving down the group. And configuration you can write very easily, I know.
Yeah.
Okay. This we discussed already in the bonding, their radius and all that. Now let's discuss melting and boiling point. Let me see. Okay. Now, please tell me what is the trend of the melting and boiling point? Are they increasing or decreasing down the group?
Is it?
Just
Wait.
see it and tell me. No need to
Oh,
apply any logic.
so it's increasing
It's
as you go
increasing.
down.
Yeah. Now let's study it. Is this board better or the previous one which we used in last sessions?
This board is good as well. I don't mind which one. They're both easy to read off.
Don't you feel any difference?
Uh,
My students told me this is better, that's why I'm using it. This is
yeah.
Microsoft board of Microsoft Office, I think something like that.
Yeah.
Earlier we used that Zoom board.
No, this one I think it's quicker. Like, when you're
It have more
drawing it.
features. You can
Yeah.
just scroll the pages. In Zoom, you have to shift to the next one.
Yeah.
Okay. Melting points and boiling points, same trend. Okay. They are increasing. Okay, now let's suppose we have a sample of bromine. Let's suppose. So there will be very large number of bromine molecules, isn't it?
Yeah.
Like just remember the case of the water. When you boil the water, what happens? Do you break these bonds or you break the interactions between one water and another water?
You break the interactions, not the covalent bonds.
No, these bonds remain intact. We just keep these two molecules far apart.
Yeah, that's why I said you break the interactions.
Okay, okay. I
Yeah,
thought you
I said
said you break the covalent. You use the
no. I
word
said
covalent.
you don't break the
Okay,
covalent bonds.
I missed
Yeah,
the word out.
yeah,
Similarly, suppose I want to boil bromine. What will happen? This bromine molecule will get farther apart from this.
yeah.
We want to do this. And please tell me what are type of interactions between one bromine and another bromine?
Is it intermolecular forces?
Which one?
Intermolecular.
Intermolecular. What are the name? We studied, I think. I don't remember.
Oh, wait. Is it Van der Waals?
Yes, van der Waals forces. Good.
Yeah.
And please tell me the van der Waals forces depend on which factor?
So would it be wait, I was going to say nuclear charge or no?
No.
Wait, Van der Waals force. Wait, what was the question?
My question is, what are the factors on which van der Waals forces depend?
What, like electronegativity?
Like, I just simplify the question. I want to ask if I have a sample of, say, fluorine. What do you think? The forces will be more in bromine or fluorine?
Will the forces be stronger in fluorine?
No, bromine, because that you need to see the type of the forces. Van der Waals forces are size dependent and mass dependent. Okay. So
Yeah.
if we move down the group, like I'm moving, like I have a sample of fluorine, then I have a sample of chlorine. Okay. So forces will be more between chlorine as compared to fluorine, even
Oh,
greater
okay.
between bromine, even greater between iodine.
Yeah.
So that's why their melting and boiling point are increases, because we need to break the van der Waals interactions.
Yeah. Yeah.
Okay.
That makes sense.
Yeah. So this is the point. Uh, Again, they have not explained that in that detail. So if you want to note, you can note down, or if you want to have recording, I'll send you.
Yeah.
And electronegativity, they have just elaborated it. You are already well aware. I'll just explain it. Just have little bit idea about the values. Fluorine value, we need to remember it's 4 on the Pauling scale, I think. We did that
Yeah.
or not? Pauling is a scale to measure the
Yeah. Yeah.
electronegativity. And chlorine, its actual value is 3.16. You can remember around 3. Just little bit idea.
Yeah.
Bromine. What happens to electronegativity when we move down the group?
It decreases.
Yeah. What is the reason?
Is it because because the atomic radius is increasing, so the nuclear charge is decreasing as well?
Uh, we can say effective nuclear charge. Basically, nuclear charge is increasing. Yes. So size
Yeah.
is increasing. That's why we can say the valence electrons are moving apart, far apart from the nucleus. So that's why
Yeah.
electronegativity decreases. Okay.
Mm.
Any doubts till now?
No, I understand at the moment.
Okay. So let's cover the topic, then we'll come back to the questions, okay?
Hmm.
I want to cover this chapter today. It's quite easy. Okay, trends in oxidizing ability. It's very easy. So can you tell me what are the topics being covered in your chemistry class of this chapter?
What do you mean?
I'm asking, out of this chapter, your teacher covered which topics?
Well, at the moment, it was only a 45-minute lesson, so we only did the experiments. We didn't do any theory or anything.
Oh, you performed experiments in lab.
Yeah, that's all we did. It was just one lesson and that's it.
Okay. So isn't it like you have separate practical classes and the theory classes?
No.
Okay.
Like according to what we're doing in theory, we do alongside the experiments.
In that same class only.
Yeah.
So the apparatus for the like experiment, is that present in your classroom only?
What do you mean? Only in the classroom?
Like I think they used to take you to the laboratory chemistry lab.
No, they're all like present in the classroom.
That's
Like our
good.
classroom is like a laboratory and like class together.
Okay. So every lesson is in that room only?
Depends. One teacher it's always in the laboratory. The other teacher she has half lessons in the laboratory, half in the normal classroom. Like yeah.
Okay. She's choosy, huh?
Yeah. Yeah.
The younger one or the elder one, older one?
The younger one, because it's difficult with the other year groups as well. Sometimes if they need to do experiment, they need to use the laboratory room.
Oh,
So we have to go in a different room.
fine. Okay, so please tell me what is the meaning of oxidation in terms of like electronic concept?
So loss of electrons.
Yes, oxidation is the loss of electron.
Yeah.
Now, please tell me what is the meaning of oxidizing agent?
So the agent that is being reduced in order for the
To
other one to be
oxidize other.
oxidized.
Yes, in
Yeah.
order to oxidize other. So we can say the species which itself gets reduced.
Hmm.
Now, please tell me, halogens, we know that they are present in group 17. And we
Yeah.
just discussed that they have 7 valence electrons.
Yeah.
So what do you think? Will they try to complete their octet?
Yeah. They'll try and complete
They'll
it.
try to complete their octet. They already have 7 electrons. Then
Hmm.
what is the easiest way for them to complete their octet?
By gaining one electron.
By gaining electron. Fine.
Hmm.
And what is the meaning of gain of electron?
Uh, reduction.
Reduction. It means halogens have very high tendency to get reduced.
Oh, okay. Yeah. Yeah.
It means halogens can act as good
Good
oxidizing
oxidation
agent.
agents.
So this is the
Yeah.
reason. Halogens can act as very good oxidizing agent. Okay.
Hmm.
Now, if you want to compare their oxidizing power, it can also be called as oxidizing power. Oxidizing agent or oxidizing power.
Hmm.
Chlorine, chlorine, bromine, iodine. What do you think? Out of these 4 fluorines, which should be the strongest oxidizing agent, Ayush?
Would it be iodine? Oh wait, no, not iodine. Sorry, fluorine, because it's able to
Yeah,
attract electron.
good, good,
Yeah.
good. Now, if I move from iodine to fluorine, can I say their oxidizing power increases?
Yeah.
Or I can also say in another words, ability to act as oxidizing agent increases, isn't it?
Yeah.
Simple. Now displacement reactions, again they are very easy. Let's see. You are well aware about the reaction. If I write zinc plus copper sulfate, you will say कि ma'am it will form zinc sulfate plus copper.
Yeah.
We call it as a displacement reaction because zinc is more reactive than copper. Okay,
Yeah.
similarly in the halogens we have displacement reactions. Like I give you example. Suppose okay, before writing the product, please tell me what is the oxidation number of chlorine here?
0.
Yeah, 0. And what's that bromine here?
Would it be -1
Yes, because alkali is always
+1?
plus.
Well, it's set numbers. Yeah.
Sorry?
Yeah. I was going to say like they don't change for the alkali and non-alkali
Yes,
numbers.
yes, they are fixed.
Yeah.
Now, out of bromine and chlorine, which one have more tendency to gain electrons?
It would be chlorine.
It would be chlorine, yes. So, chlorine will gain electrons and change to,
Oh, Cl1 minus. Yeah.
its name is what?
Chloride
Chloride.
ion.
It will change to
Yeah.
chloride. Okay, and you see it's gaining electron from what? From bromide ion?
No, would it be from the
1 minute, 1 minute.
sod?
I'll simplify it. Just give me a minute. Leave the sodium, just write it in the ionic form. If I
Oh,
write it like this, it will gain electron because we are discussing that it is more electronegative than bromine. It has more tendency. It will gain and change to chloride. And
chloride.
it's gaining from what?
Or
Bromide
from the
ion.
brom. Yeah.
So bromide ion has to do what? Has to lose electron and change to bromine gas, isn't it?
Yeah.
So if I balance it, I'll write 2 here, 2 here. So
Yeah.
what's happening in this reaction? If we write their half reactions, how you will write? You will say like it's in terms of electron, you can write like this. And what's happening to bromide ion?
Or is bromine being reduced?
Bromine being oxidized, not reduced.
Oh yeah, sorry, loss of electrons. Yeah, oxidized.
Yes,
Sorry.
it is being
Yeah.
reduced, it is being oxidized.
Yeah.
So we can call it as a displacement reaction. Now, actually the bromide ion don't exist like this. It will exist in the some form of compound like sodium bromide. So what will happen? It will form NaCl and it
Yeah.
will liberate bromine gas. You will put 2 here. I have just written this ionic equation to make the things more clear.
Yeah.
So, isn't it the sort of displacement reaction?
Yeah.
Chlorine has displaced bromine from the solution and itself formed the compound. Okay.
Yeah.
Now tell me. Okay, just tell me. Is this reaction possible or not?
No.
Yeah, this reaction will not take place because,
Because fluorine is more reactive than chlorine.
yes. Can the opposite take place?
Yeah.
Suppose I write like this. What will be the product? What you will write?
NaF
Plus?
plus Cl2.
Yes. It means the more electronegative halogen can displace the less electronegative halogen from its solution.
Yeah.
Simple idea. Now you see they have represented it in this table form. Just see this. This is fluoride ion. Can you displace fluoride ion with chlorine?
No.
Neither with bromine nor with iodine.
Yeah. No, you can't displace
But
any.
we can displace chloride ion with fluorine because fluorine is more electronegative, but not with these two.
No. Because
Similarly,
bromine.
bromide with the two above, not with iodine. Iodide with everyone because it is the least electronegative.
Yeah.
Okay.
That's one of the experiments we did. We had to experiment if with all the different halides and
Formed, I think, the
halogens.
precipitates.
Yeah. So if it formed the precipitate, then displacement whichever precipitate was present, we had to say like, if it's been displaced or not. So if there's a chloride ion, then we add iodine solution to it. If the precipitate is purple, we know that displacement reaction hasn't occurred because yeah.
So, did you perform two sets of reactions?
Say that again.
I'm asking, did you perform two types of reactions in your laboratory on that day?
Well, what two types of reactions?
Actually, see, for the detection of halide ions.
Oh yeah, we did that as well.
Okay. So you did displacement reactions as well as the detection of the halide ions.
Yeah, and we also did the solubility one, I think.
Solubility product?
Yeah, so the solubility of halides and solubility of halogens in water.
Okay.
So we added, we just had water and then we added either the halide form or the halogen.
So what was the result?
Wait. I think it was the halogen that was more soluble because it was.
Okay,
Wait,
but the
I'm not sure.
solubility experiments are not given in your textbook. The rest
Yeah.
are given, displacement and the detection of the halide ions.
Yeah, I think we did do solubility. I'm not sure though.
Okay. Are you used to make any files of like any record of your practical observations?
Yeah. Well, we had to fill out a table. Well, I haven't filled out the table because I was doing it online. But wait one sec. Should I get the papers just over there?
Yeah, show me if you have.
So we take pictures of the results as well, like so we can observe them again after. But okay. Yeah, so we did this one. Oxidizing.
Yeah. Okay.
So that's the one that you just showed now. And then we did just one called Halide Ion Test.
Yes, I got it.
Yeah. And then there's another one where we test for halide ions, but we don't know which sample we're using. So in this one we have unnamed samples,
Okay.
but we haven't done this experiment yet.
So where is the solubility experiment?
Well, wait. I don't think we got a table for that, but I'm 100% sure we did the experiment, but I can't find any record of it. I think it might be in a different folder, which
Okay.
I have in my locker at school, but I'll try and find out.
Yeah. It's possible that may not be in your syllabus, that experiment. So that's why your teacher not recorded that observation.
Say that again?
I'm saying, is it possible that is not in your syllabus? That's why you may not recorded the observation.
1 second, let me fix my internet. 1 second. Hello, can you hear me?
Yeah, I can hear you.
Yeah.
Okay. So displacement reactions and oxidizing ability is clear. Okay. Now
Yeah.
this is just the extra information, not that much dealing with the chemistry. You can read yourself. Okay.
Yeah.
If you don't get it, then we'll discuss it.
Yeah.
We'll discuss the questions just after completing the topic.
Yeah.
So after this chapter, I think you are going to start with the organic chemistry. I checked your book. So if I show you,
No. Wait, are we?
it's written.
No, I think we're starting with we are doing inorganic chemistry, but for some reason we started on halides. I'm not sure why. I think it's because of the experiments. The teacher said, you know how we're doing oxidation
Hmm.
previously. I think she said there's a link between the um, redox chapter and this chapter because of the oxidizing powers,
Yeah.
oxidizing
Actually,
agent.
the every inorganic chemistry chapter is based on redox and periodic table.
Yeah. So
Not
I think
particularly this only. Hmm.
yeah, I think we're doing this whole chapter of periodicity, but I don't know why we started with halogens,
Hmm.
unless we are going to organic. But I'll ask the teacher if we are going to organic.
Yeah.
Hmm.
It will be easier if we start it before your class teacher.
Yeah. Well, I have one lesson with her tomorrow, so I'll ask her.
Okay, tomorrow on Monday, tomorrow. Okay.
Yeah,
The
and that's
lesson
the
will be
only.
this group 17 only.
I think it will only be on group 17 because she hasn't explained the theoretical part of the experiments.
Hmm. Okay.
Hmm.
We just discussed their oxidizing power of halogens, isn't it?
Yeah.
Oxidizing agent X2 means halogens can act as oxidizing agent. But from the displacement reactions, we can also discuss about their reducing power. How? Let's see. I'm writing again this reaction. Sorry. Now, tell me in this reaction, which species is acting as an oxidizing agent? Just tell me that.
So the pink. Gain of electrons. So would it be chlorine? Because it's gaining electrons.
Yes, chlorine is the oxidizing agent. And
Hmm.
can we also mention which species is the reducing agent here?
So bromine.
Isn't it the bromide ion?
Oh yeah, yeah, bromide ion.
Yeah. And similarly, first, let us discuss, is this reaction possible or not?
Yeah.
Yes, this is possible. Now, tell me about the oxidizing and reducing agents in this reaction.
So would the oxidizing agent be the fluorine, and then the chloride ion is the reducing agent?
Yes. From this discussion, can't we say that X negative? What should be the name of the X negative in journal, Ayush?
But like the iodide, but no,
Halide.
halide. Oh, halide.
We
Sorry,
call them as halide ions. Okay. So
halide.
from this
Yeah.
discussion, we can say that halide ions act as reducing agents as well.
Yeah.
I should not say as well. Halogens act as oxidizing agent, but halide ions can act as reducing agents.
Yeah.
Now, like we discussed their trend of the oxidizing power, or we can say we discussed their tendency to act as the oxidizing agent. Similarly, can we discuss their tendencies to act as reducing agents? Let's see. We have fluoride ion, bromide ion, and iodide ion. First, before discussing their trend, do you understand the word trend?
Yeah.
Okay.
Like.
Before discussing their trend, if we discuss why they are acting as reducing agent, you will say because they are losing electron,
Yeah.
because they are
Losing electron.
losing electrons. Okay. Now, for which ion losing electron will be the easiest process?
Would it be the iodide ion?
Iodide ion. And it would be most difficult for
The fluoride ion?
fluoride ion. It means if we move from fluoride to iodide, their reducing power will increase.
Yeah.
Simple. That's it.
Oh, okay.
Clear?
Yeah.
Concepts are very easy in the inorganic chemistry. So
Yeah.
just the understanding of periodic table chapter is necessary, as well as you can say some understanding of redox.
Yeah.
You can see increasing reducing power. They have related it with the size. Definitely it's related with the size because iodide ion is the biggest one.
Yeah.
So if it is the biggest one, isn't it the loss of electron for it is the easiest one?
Yeah.
Hold of the nucleus will be the least. So loss of electron will be most easy for iodide ion. Or we
Yeah.
can
But
say, yeah,
I was going to say, earlier how you showed us how you showed the actual trend, where it was chlorine, bromine, fluorine, iodine. Would it not be easier for fluorine to lose an electron than bromine?
you are just confusing that we were dealing with F2. Here we are
Oh,
dealing
okay.
with atom only.
Oh, okay.
Bond
Yeah. Oh,
energy
okay.
deals
Yeah.
with
Yeah.
this. Okay. Yeah.
Yeah. Yeah. That makes sense. That's fine.
All these are the atomic properties dealing with atom. That was the bond energy molecular property.
Yeah.
So now the some reactions are there. Reactions of sodium halide with concentrated sulfuric acid. It's very interesting. Reactions are given in your textbook. So let's discuss these. Okay. So are you used to take notes when your class teacher teach you?
Yeah, I normally take notes.
He also gives notes, now you told me.
Well, they sometimes gives if it's like a lot of information that is just wasting the time to write it down. She normally just gives it written down already.
Okay. Okay. So then what is the study material for you people? The just this textbook or her notes?
Well, there's another website called Moodle. It has all the like resources like the
Moodle?
PowerPoints. Moodle, Moodle.
Okay. Please send me the link
Uh,
after the class, okay?
yeah, I'll send you the link.
So very
And I
interesting
think
names are there. Moodle.
yeah, yeah, like this one is called Carboodle. I don't know what it.
Oh,
That's the textbook website,
that's
and
the study book.
that.
You can
Hmm?
also provide me the link. We can also discuss that also. If some extra points are there.
Yeah,
But I feel your
yeah,
this book is also quite good.
yeah, yeah. But I think now that they're trying to make everything all digital, even the textbooks. Everything's going to be digital, and like I have two medicine exam in the September and November, and
This
they're
year?
both digital yeah, this year. It's nothing related with like biology, chemistry or anything. It's like IQ test.
Oh, aptitude.
Yeah, so that's one of the tests, and then the other one is like ethics of medicine, or like the different aspects of medicine. What would you do in this situation and whatever.
So how
There's
you are
more to it.
preparing for that?
Well, those exams, you can't use like textbook or tutoring or anything. You have to practice yourself over and over and over. But they say you shouldn't practice too early or too much. Like you should practice for approximately 6 weeks and maybe do 100 to 300 questions per day. It's like because you need to be fast, you need to think fast, and you know,
Are you doing
so
that?
not at the moment because the exam is maybe in 9, maybe 7, 8 months. So they normally say ideally you want to start practicing 1.5 month before the test,
Okay.
because I want to focus on my main exam as well. I want to get
Why they
my.
are taking exam in your 12 level? Shouldn't be after your next year 13 level.
No, because we're applying for university this year.
You were earlier saying after level 13 you will be in the university, isn't it?
Yeah, but you apply for university at the end of this year. So summertime, you write like your personal statement, you do whatever like work experience, volunteering, whatever.
Oh,
Like I applied for hospital job,
okay.
and I think in 3 or 4 weeks I'm going to start working in hospital on the
Oh,
weekend
great.
or Fridays or whatever. And they will train me and like show me if I can see some surgical rooms, theaters, and I can observe them, make notes, and then write in my university application. The reason I want to do medicine is because of this and this. I did this and this.
Oh,
So
so you want to go in medicine after
yeah,
13. You want to be doctor.
yeah. Like I want to go into. I want to specialize into something in the future, and I'm quite interested in medicine and make a difference.
Okay,
So,
that's nice.
mhm.
Okay. So reactions of sodium halides with concentrated sulfuric acid. What should be the general formula of sodium halide? Shouldn't
Oh,
be
would it be
NaX.
NaX? Yeah.
So we are dealing with NaF, NaCl, sodium bromide and sodium iodide, because we have these halides with concentrated sulfuric acid. Okay. Let's see the first reaction. First of all, we'll start with NaCl. If you perform this reaction, you will get this as the product. Can you name this? It's called?
Sulfuric acid? Oh wait,
No.
Oh no, mind. No, sorry, no.
It's sodium hydrogen sulfate.
Sodium hydrogen. Okay.
Like, okay.
Oh yeah.
This is Na2SO4. It's sodium sulfate simply.
Yeah.
And if it is NaHSO4, it is called sodium hydrogen sulfate. Okay?
Yeah. Yeah.
Yes. Now, if we see what is the oxidation number for sodium here,
+1.
this -1,
Yeah.
please find that of sulfur.
Sulfur is 6. Would it be wait, -8, 8. Wait, would it be +6?
Yeah, you can calculate, no? Like X plus.
Because I was, yeah. Because hydrogen would have to be 2+, sulfur would be 6+, and then oxygen would be -8 in total.
Yeah. Okay. If I ask you that of sulfur in this compound, what should be your answer?
Would it be 2+?
2 minus.
Oh wait, or 2 oh, okay, yeah, because it's,
Yeah. So make a habit to calculate.
yeah.
What will be like, you will have more correct answers. Okay. And sodium here, what should I write?
Would that be +1 as well, because it's set?
Again, sulfur. Okay. Oxygen -2, hydrogen +1. What should I write here? Here.
So oxygen would be -2 as well. So
Yes.
8, and then would wait, what's that on?
Just
1
take pen
second.
and calculate and tell me.
+1. Wait. Well, would hydrogen be? Wait 1 second. Would hydrogen have to be +1 and sulfur +5? Wait, no.
If it's +1, how this is +5?
Oh wait, no.
It will be +6, no? Let's see. You just take it
Oh
as,
yeah,
okay? No need to
yeah.
get confused. It's very easy. It's +1 for sodium, +1 for hydrogen, and +4 into -2 equal to 0, isn't it?
Yeah.
So it will be how much? +6, simple.
Yeah.
Just make a
Yeah.
habit to calculate like this. It will always be correct, okay? And here,
Would it hydrogen be? Wait, hydrogen +1, chlorine -1.
so can I call this reaction as a redox or not?
Well, no, because nothing. Wait.
Yes, this is not the redox reaction.
Yeah.
Okay. Actually, why we are studying these reactions, I tell you, the concentrated sulfuric acid, it has two properties. We know very well it's an acid. Okay.
Hmm.
Why I'm not able to write? Let me write. It acts as acid as well as, if you study concentrated sulfuric acid, it is a very good oxidizing agent as well. Just general properties. These two are the properties of concentrated sulfuric acid. Now, but in this reaction, it is acting only as an acid, not, it is not showing its oxidizing power here.
Yeah.
You see, if it acts as oxidizing agent, what is the function of the sulfuric acid?
If as
Anything
act
acts as oxidizing agent, it should itself gets reduced, isn't it?
yeah.
It should itself being reduced, but its oxidation number is not changing. It remains 6.
Yeah.
It means its reduction is not taking place.
No.
It means it is not showing its oxidizing power here.
Yeah.
It is only acting as what?
Just
Only
an
acting
acid.
as acid. Clear?
Yeah. Hmm.
Or we can also represent it in another way. What is the another way? See, we discussed that halide ions also act as reducing agent,
Yeah.
but chloride ion is not acting, is not showing its reducing power here because it is remaining as such.
As a halide.
Here also Cl-1, here also Cl-1.
Yeah.
Suppose our product was, suppose Cl2, but it is not the actual product, we are just supposing it. Then can we say it's acting as a reducing agent?
Yeah.
But we are
Because it's
not getting
gaining a
chlorine. It means it is not showing its reducing power here.
Yeah.
So in comparison to sulfuric acid, just remember, you can say the discussing the reactions of the sodium halide with sulfuric acid, with sodium chloride as well as sodium fluoride. If you study this reaction also, you will get the same products. What are the same products? It means in this reaction as well, acid is concentrated sulfuric acid is showing only its acid property.
Yeah.
What is another property? Oxidizing agent, but it is not showing here.
Yeah.
And as well as fluoride, and they are, we know, very poor reducing agents.
Yeah.
Best reducing agent are what? Iodide.
The iodide.
They are very poor reducing agent. We can also prove from this reaction. And chloride as well. Chloride is not able to show its reducing ability in this reaction. Okay.
Hmm.
And if you perform this reaction in the laboratory, you will get its steamy vapors. Actually, you know that HCl is basically a gas.
Yeah.
But in your laboratories, you must have seen the bottles on which hydrochloric acid is written.
Hmm.
Have you seen that?
Yeah. Yeah. We have the
What's
bottles.
that? They basically dissolve HCl gas in water.
Oh, okay.
Hydrochloric acid is what? It is the solution of HCl gas in water. If you dissolve HCl gas in water, no? If I write the reaction, what will happen? HCl in water, it will form hydronium ion and chloride ion. And in your that bottle, these ions are present basically. Okay. So HCl in the form of gas is released here. And because in air there is moisture, so we'll get as white fumes we can see in this reaction. And
Yeah.
usually this reaction is not performed because HF is a very strong chemical. It
Yeah.
can even dissolve your glass.
Oh.
So that's why it's not performed. You must have
Yeah.
seen on some glasses there's some designing, some flower patterns are there sometimes. Designer
Uh,
glasses. Have you seen?
but yeah, I've seen those types of glass, but not but what in the laboratory?
No, no, in general, not in
Oh,
laboratory.
okay. Yeah.
Yes, in our houses, homes for decoration or
Yeah.
something. So that
Mm.
HF is used for that phenomena. It's called etching of glass.
Mm. But what's that used for?
Etching of
Wait, so
glass. Like
what is?
they make some pattern on the glasses by dissolving the glass from that area
Oh, okay.
because it's a very strong chemical.
Yeah.
So with these two fluorides, halides, sodium fluoride and sodium chloride, sulfuric acid will show only its acid property.
Yeah.
And fluoride and chloride, they are weak reducing agent. That's why we are not getting F2 and Cl2. Okay.
Yeah.
But there is a change in the reaction if you take another halides, sodium, bromide, and iodide. What will happen? Let's see. This is the sodium bromide. Actually, two type of reaction will take place. You will see different products. One is on the same line. Isn't it on the same line?
Yeah.
This reaction will also take place, but along with this, what will happen? Bromide ion will show its reducing power by itself getting oxidized.
Oh, okay.
So what will happen? These electrons, sulfuric acid will take these electrons. The medium is acidic. Medium acidic means if we have sulfuric acid, by default, we will have H plus ions.
Yeah.
And what will happen? You will get
Would you get water
1
molecules?
minute, yeah,
Yeah.
2. Yes. Now tell me the sulfur oxidation number here and here.
So +4. So okay. Wait, 8. So is it +6 on the reactant side and +4 on the
Yes.
yeah.
So if I write these two in combined form, you know how to add the reactions, reactant on reactant side.
Yeah.
We learned this in Hess law during studying.
But so would the electrons cancel out?
Yeah. So I'm not going to write it again. Like if I rub it, one and the same thing.
Yeah. Oh yeah, our teacher showed us something like this when we were finishing off oxidation. But one thing I didn't understand was how she got the number of the moles of hydrogen on the reactant side. So on the reactant side you put 2 hydrogen.
Yes.
How did you get the 2H plus?
Actually, there are certain two methods are there to balance the equation in the redox.
Hmm.
Uh, did you study that in your class? There is half equation
Yeah,
method and oxidation number method.
yeah. Our teacher like made us practice this. I was able to do it, but I didn't understand how to actually do it. If that makes sense.
You told me yesterday that redox is clear. That's why I didn't start with this topic. We must.
Yeah, but I don't know. The way our teacher teaches is like she tries to link all
Problem.
the
I
topics
teach you
together.
this in the next lecture if you want. These are quite
Yeah.
important. oxidation number method and ion electron method.
Okay.
I have gone through your book. I think these methods are mentioned. But yesterday I thought
Okay.
that these are clear to you. That's why I did a
Yeah.
start that.
Yeah.
We'll
Because when you said
easy. Methods are quite easy. Just one time understanding is required.
yeah, I just need to understand it because I understand like how to do it. I just don't
No
understand what it actually
problem.
means.
We'll have one
Yeah.
lecture on that. Okay.
Yeah.
Okay. So I'm saying you will get two reactions. One is this and another is this. Now, in this reaction, can we say that bromide ions are showing its reducing power?
Yeah. Because it's going from bromide to bromine.
We'll see
Gas, yeah.
reddish brown color bromine because bromine in its neutral form is reddish brown liquid, no?
Yeah.
And also SO2 will be formed. And in this reaction, I am saying with NaBr you will get two type of reaction. One is this, another is this. Here it is showing its acid property. Here it is showing its oxidizing power.
Just 1 second. 20, 30 minutes, 20, 25 minutes. Yeah. Okay. Yeah. Can I get wrap or no? Yeah. Instead of wings. No wings. Yeah. Yeah, burger and wrap. Okay. Yeah. Sorry.
Yes. So oxidizing agent means itself getting reduced.
Yeah.
So it's changing from +6 to +4. Isn't it reduction?
Yeah.
So
Because yeah.
it's what? Gain of
It's gaining electrons. Yeah.
Gaining electron is reduction, so acting as oxidizing agent. We
Yeah.
just mentioned that sulfuric acid has two properties. What are those?
So the acidic property and then the oxidizing agent property.
Yes, this is proved the reaction with NaBr. Similarly with NaI, it is also proved.
Yeah.
And with NaI, it shows two type of reaction. One is just simply based on its acid property. Do you remember its name?
For what? Oh, would it be sodium hydrogen sulfate?
Yes. Okay. And another property, its reducing power. What should I write here, Ayush?
I2.
Plus?
Plus 2E minus, yeah.
Yes. And interestingly, what happens? Why I'm writing 8 here, I tell you, just wait a minute. Will be, yes. If you want to write the equation collectively, you have to multiply it by 4. Okay, let's see. Now tell me, what is the number here? We know +6.
Yeah.
And what's number here?
Plus, what was this?
Sulfur, oxidation number.
Oh, would it be -2?
-2. Now please tell me, if I ask you going from +6 to -2, how many
You
electrons?
need 8 electrons.
How many?
8.
Yeah. Which side?
But you add it on the left side.
Yes.
So it'd be plus 8, yeah.
Very good. Now see, going from +6 to -2, is it reduction or oxidation?
Gain of electrons, so it's reduction.
It's reduction. In the reaction with NaBr, we were saying it's going from 6 to 4. Is it
Yeah.
reduction?
Yeah, it's reduction as well
In
because it's
both
gain of
cases,
electrons.
reduction is there. Fine.
Yeah.
But the compound is different. Here SO2, here H2S.
Oh yeah. Yeah.
In which case more reduction. We can say more reduction. This.
Oh, okay. Yeah.
Why more reduction?
Because
Because
it's
iodide is having more reducing power here, isn't it?
yeah.
More reducing power means it has tendency to lose electrons greater than bromide.
Yeah.
It is losing electron easily, or you can say it can lose more electrons. Naturally, sulfuric acid will gain more electron and will get reduced further to -2 oxidation state.
Yeah.
Are you getting my point?
Yeah, I understand that now.
Actually, what happened with NaI, it passes through different states. Sulfur from +6, you will get some +4 also, some 0 also, -2 also. Main compound will be this, and this is a gas with the egg rotten like smell, rotten egg like smell,
Yeah.
hydrogen sulfide. You will also get some neutral sulfur. It's yellow color sulfur will also be there. And some SO2 will also be there. But we don't write these, we write the main compound.
Yeah.
Basically, all these are found because iodide is a very good reducing agent. It loses electron easily. That's why sulfuric acid is gaining electron easily and acting as oxidizing agent as well.
Yeah.
So from these two reactions, it's very much clear that sulfuric acid, in addition to acting as acid, can also act as an oxidizing agent.
Yeah.
And from this reaction, we can also compare the reducing powers of different halide ions. Isn't it?
Yeah. Wait, so in this like this reaction specifically, would the color of the like at the end of the product, would it be purple?
Yes. From that only we got to know that it has reducing power.
Mm-hmm.
Purple
And
color and you see rotten egg like smell and some yellow color sulfur will also be there.
yeah. Yeah.
Okay. All these are mentioned here. Take 1 minute. They have written in one line. I have split it in two parts. Like this also.
Yeah.
This is comparatively easier by splitting into two. Why I multiplied it by 4 so that I can cancel the electron. Now why I have added 8 electrons?
Yeah.
Because sulfur is moving from 6 to 2. The requirement is of 8 electrons. And why 8 here? Because we know that water will be the product. Oxygen are 4, so we need double hydrogen.
Yeah.
So by default it will be 8. But there are certain rules which we learn in that methods, oxidation number method.
Yeah.
Then they have written in one line only. Okay, you can split it and they have mentioned here the method which we are discussing, oxidation number method, and by splitting the equation, this is only that method.
Yeah.
Now these are the reactions which you performed in your laboratory experiment. Precipitation, detection of the halide ion. On next weekend, what topic should we start on next weekend?
What I'll do is next lesson I'll ask my teacher if we're continuing with
If you want, we
periodicity.
can cover that, the remaining portion of the redox, which you are just telling me the methods to balance the equation, and the questions of this chapter are also there yet to be discussed.
Yeah, so we'll do that part as well. And if we are continuing with periodicity, then we'll just do that then.
But group 17 is complete.
Yeah, group 17 is complete.
So will they start the, I think group 2 is also there, right?
Wait, but do I need to learn the rest of it? So
What?
the use of chlorine,
I don't think
because there's a
that you need to
there's
ask
a
your teacher.
because there's a term called disproportionation,
Yeah,
which
that will
came.
discuss.
Yeah, if you can explain that as well.
Reaction with alkylates also. I think it is in your syllabus.
Hmm.
Then they have lot of practice questions.
Yeah. Training a lot here.
Oh, I'm thinking it's sunny day at your side.
No, it's very sunny, but it's also very rainy.
Oh. So what is the schedule on week? No outing,
Say
nothing,
that.
only study.
Say that again.
I'm saying what is the schedule on weekends? No outing, nothing, only study,
No,
study.
I went out last night. I went to a concert.
Oh, with family?
Say that again.
With family? You went with family or friend?
No, I went with friends.
Okay.
And then had fun. But what I did was I studied. Well, because we didn't do our session, I just did biology homework and then whatever else. Got a haircut and then
Yeah, I
went to
can
the
feel.
party.
I was
Yeah,
just going to ask.
yeah. Because my hair was getting too long, so I wanted to cut it.
Oh,
Yeah.
so do you like Indian food or the food of any special food of England?
Not really. Like they say the main food here is butter chicken, so that's Indian anyways. Like that's the country's national food.
Oh, butter chicken,
So
national food. Oh my God.
yeah. So I most of the time we eat Indian food anyways. Like now today we're eating KFC, but it's just the weekend, so there's no cooking or anything, and
Oh,
we just eat
so
outside.
on weekends, no cooking?
No cooking on Sundays. Sundays we always eat out.
Okay. So you are non-vegetarian?
Yeah.
So
The
which
only thing
Indian
we
dish
don't do
do
is
you like the most?
sag.
Oh, that's great. And with makki ki roti?
Hmm?
It's special roti is there, no? Chapati, makki.
Oh yeah. Yeah.
Oh. So
Well,
is it
you know.
available here as well? Saag and all that.
Yeah. Yeah.
Oh,
We can get like all the vegetables, and everything, all the herbs and everything, so it's fine.
oh, it's great.
Mm.
Now, which halide ions we have? Fluoride, chloride, bromide, and iodide. What is
Yeah.
the meaning of detection? Like some experiment should be there, the result of from the result of that, we should say we have this halide, we have this halide. Okay.
Yeah.
So suppose in a test tube, we have NaCl aqueous solution. Now, if you have aqueous solution, there will be sodium ions and there will be chloride ions.
Yeah.
So, what you must have performed in the laboratory, you must have added nitric acid. Did you?
uh Nitric acid.
And after that, silver nitrate.
I remember we added silver nitrate, and then we added the halogen again. Wait.
It's necessary to add nitric acid.
Actually, yeah. We might. Yeah, I think we added nitric acid.
Okay. So you will get white precipitates. Did you get that?
Yeah, we got white precipitates.
Okay. Actually, what happens from the chemistry point of view, why we add nitric acid? Actually, when you take halide, generally there are certain impurities of carbonates and hydroxide in it. There's like, you can say, present in the sample only. If you take chloride sample, chlorides are basically what? They are the salts, no?
Yeah.
Like chloride salt, fluoride salt, they are salts. Okay. So these are the impurities generally present in them. So we can think like what will happen if we don't remove these impurities? What is the need of nitric acid? Suppose we don't add it. What will happen? You will have carbonate ion in the solution as well. And when you add silver nitrate solution, this is also aqueous solution, means you have silver ions and nitrate ions. Fine.
Yeah.
What they will do, silver ions will combine with carbonate ions. And what they can form, they will form silver carbonate, and it also has white PPT color. Then you can confuse that whether it is due to AgCl white precipitates or due to silver carbonate.
Okay.
Avoid this type of problem. Before adding silver nitrate, we add nitric acid. What is the function of the nitric acid? Nitric acid basically will give you H plus and nitrate ions. They will convert carbonate ion into carbon dioxide. And it will be removed in the form of gas, so it will not interfere in the reaction. And
Yeah.
it will convert hydroxide ions into water. So what is the main function of adding nitric acid? To avoid the formation of the silver carbonate and silver hydroxide. If you don't
Yeah.
remove this, it can combine with silver and form silver hydroxide. It also have certain like brown color precipitate, light brown color. We may confuse it with the presence of chloride.
Yeah.
So after removing these impurities, if we add silver nitrate, what will happen? If you have chloride in the solution, you will get Ag plus and Cl negative. They combine and it forms AgCl solid, and it is insoluble. That's why it forms PPT.
Yeah.
Similarly, if instead of like suppose you have sodium bromide in the as the halide form, then silver ion from silver nitrate and bromide ion, they will combine to give you the AgBr precipitates.
Yeah.
It's also like light cream color. Okay, the color mentioned in your textbook. Similarly, if you have iodide, it will form AgI-PPT.
Yeah.
Actually, it
I
has
think
slight
what
yellow tinge in it. It's not mentioned in your book. It has slight yellow tinge. Did you
yeah.
get that? Yellow PPT.
Yeah. Wait, I think in some of the experiments we added, I think it was hexane to bring out the color more. I don't know if it was in this one, but I think in the previous one, like the displacement reaction, to show the color more, we added hexane.
Hexane.
I think it was hexane. Wait.
I need to check that. That's not in my mind right now. Some different
Maybe.
compounds are there actually.
Maybe I don't think it was in this one because this one we were able to see the different like
PPT.
the
Okay.
different
Clearly.
yeah. Yeah. Like we could tell, which one was like slightly yellowy, more creamier, and then
So did you add in displacement reactions?
I think we added in displacement reactions.
Just
We
confirm
was
what was the chemical. I'm not sure. I
yeah.
never added. I'm not sure.
That's fine. Yeah,
Check
I'll
it
find out
online
which.
or get it confirmed from your teacher.
And wait,
Or you can also search it how it brings color. What is the chemical?
what?
Then we will study. I'm also curious about it. How it helps in
Yeah.
bringing color more.
Yeah. One second. Sorry. So yeah, it says hexane will be added to provide evidence of reaction since the halogen molecule will remains after. Uh,
Have you
yeah,
checked
and it
this
forms a
online?
yeah because when we added the hexane into the displacement reaction, it formed two layers, and we were able to see the. I think it was like two. We were able to see the color more clear.
You just send me the link. I'll get to it.
Yeah, well, I just searched on Google like what
It
is the
can
purpose
also
of.
be asked what other chemical can we add?
Hmm. Yeah,
Why hexane? है ना? These type of questions
yeah.
arise.
Like we weren't allowed to add a lot of hexane because it's very toxic. So
Hmm.
we had to use the fume cupboard and then add it. So
Yeah, okay. That's very great fume cupboard. We also used, I remember, in my post-graduation times.
yeah.
Quite interesting. So you wear
Hmm.
glasses and all? Lab
Yeah,
coat?
we have to wear. We're ordering lab coats, I think this month, but we got given the goggles at the very beginning.
Oh, we used to wear lab coats. It was very necessary.
Hmm. Like the experiments at the moment.
We used to came back from the lab with some stains on the lab coat of some acid with some holes sometimes.
Yeah, yeah. It like depends on the experiment. Sometimes we might need gloves or
Yes,
but
yes.
we always need goggles no matter what.
There is a
So,
chemical called pyridine. It's also very toxic. In the
hmm.
postgraduate times, we used to this chemical, so that's why I think fume cupboards we used.
Yeah, yeah,
Okay, then please tell me about the next topic, like before 2, 3 days before the class.
yeah,
Okay?
yeah. I should be able to find out tomorrow, so I'll send a message and then
Yeah,
yeah,
that's you can
yeah.
send me by Wednesday. No, no issues.
Yeah, okay, yeah. Thank you very much. Yeah.
Okay, good night. Good night from
Good
me.
night. Yeah. Good